I'm really excited to be here with y'all to talk about Observable Framework and getting data past the last mile. So, the first thing that I wanted to do was introduce the last mile problem so you could understand what this problem is that we're solving at Observable. So, one of the biggest problems and hardest challenges with creating awesome data visualizations and data apps is speed. So, no one, developers, end users, decision makers, no one wants to wait for pages or charts to load. We expect kind of instant gratification when we click on a data app. We want instantly loading charts that we could interact with in a really fluid way. But that's not always what happens because, well, there have been these really amazing advances in speeding up things like ETL pipelines and querying really huge databases, for example, using DuckDB, running models faster. Oftentimes, even though those processes for data access and wrangling and modeling have become a lot faster, analysts and developers can oftentimes find that their work and their data products are hung up right at the last mile of their data work, which is when they're trying to create and deliver really fast and rich interactive visuals that communicate the important findings of their work to end users and decision makers. And often that happens because we're asking for a lot to be done right at the moment when a user opens up your app. So that can include things like time consuming analysis and modeling. For example, if your app has to actually like query a database and then compute something in order for a visualization to appear, then if that's happening the moment that a person clicks on your link, then they might see like a spinning wheel. Well, they have to wait, and that can cause some frustration. So those time consuming client side data processing things can slow up app loading and data visualization loading. And second, just if your app requires a lot of data, especially excess data, to load before your visualizations show up, then that can take some time too. And both of those things combined, when they happen right when a user clicks on your app link, can bog down your page and make visualizations really slow to load and even miserable to interact with. Both for developers who are trying to build and iterate really nimbly, and also, and most importantly, for end users who are trying to learn something from those visuals and want an engaging and seamless and fast experience. And unfortunately, that means that last mile of data, which should be this really exhilarating phase when you're bringing all of your data work to the forefront in these awesome, rich, interactive data visualizations, can actually become this really demoralizing graveyard of all of your great and ambitious ideas, your dreams for really performant apps, and your goals of giving users richer insights. And what happens is when that occurs, data visualization developers and app developers are often left feeling like they have to make this trade off between app speed and performance and just making like the really awesome data displays and visualizations of their dreams. And we don't think that data visualization developers should be in a position where they're having to make this trade off. So, what's our solution? Well, here's where I tell you that we don't have a magic pill that makes all of your client side queries and models run instantaneously. This would be a different talk if we did. But what we do have are ways to be more strategic about when those slow things happen. Because when slow processes happen is something that we can control, and that can have a really good impact on what your end users experience. So, Observable Framework's solution to the last mile problem is what we call baked data architecture. And baked data architecture lets you be strategic about where your data bottlenecks occur. So instead of having this really common scenario where slow data loading and processing happens and is experienced and felt by your end users when they open a page, meaning that they can oftentimes feel frustrated and be less likely to return, which is not great when a lot of like business models and the value of people's work depends on return visitors to those data app and visualizations, that instead of having these things happen at the moment when a user opens your page, then instead, can we push that slow stuff to happen behind the scenes at build time where it can go unnoticed by your users? So, if we can push this bottleneck to earlier in this data work process of developing and deploying your data apps, then we can pre-bake everything that needs to be then shipped to your users, so that by the time that they actually open your page, they get this really fast experience where they're not waiting for charts to load, even if they're really rich. And I'll show an example of this later, of the kind of displays that we can create that still maintain their performance. So, how does this all work? First, I'm going to briefly introduce what Framework is, and then I'm going to jump into more detail about how that baked data architecture helps you make faster visualizations and data apps. So, Observable Framework, we launched in February of 2024. If you had heard of Observable before, you might have worked in our browser based notebooks for data visualization. Framework, we launched in February. It's a static site generator, command line interface, and local preview server combined, specifically for creating data apps with stunning data visualization. So it has a lot of your modern tools for data viz like D3, Observable Plot, Mosaic, VG Plot, etc., already available by default. So the command line interface for Observable Framework provides really helpful commands to do things like create your new apps, open the preview server, build a site, deploy it to Observable or somewhere else, and more. So that's really your starting point for making your Framework data app, and has other helpful commands. And the meat of Observable Framework, though, is the static generator part. So you can create framework pages in Markdown, which then get packaged together along with any necessary data, configuration options, CSS style sheets, etc., on build before being sent to the client where users can see and interact with them. So, different from browser based notebooks, Framework is all files and code based, which is really nice because you're, one, not limited to pre built components or chart types that you might experience with other BI tools, for example. And also, since you build locally and it's all in files, it really fits nicely into existing data analyst and data scientist workflows. For example, if you're using version control with Git. So, really nice for like the flexibility of building data apps with code, and also really nice that it's local files based, so it can fit into existing data workflows. And finally, because when you're working locally, you also want to see what you're working on while you build and iterate. Framework also comes along with a live preview server that you can initialize just with one command. And as you edit your code, that means that the live preview is automatically updating on save, so that you can see what you're building right as you're iterating on your visualizations. Framework also, like I was saying, comes with a bunch of really nice JavaScript libraries for data visualization and analysis that are already built in. So really, once you run your first command to create your Framework data app, you can jump right into building pretty quickly. All right, so that's a little introduction to what Framework is. But now I really want to focus on how does it actually get your data past the last mile? And there are really two parts to this, which combine into that baked data architecture that I mentioned. Baked data, meaning that everything is run, built, and packaged together before you ship it to end users, not baked data as in manufactured data. So those two parts that I'm going to focus on are data loaders. That's where I'm going to spend most of the time today, and our static site architecture. So I want to start with kind of a philosophical introduction for data loaders, and then I'm going to get into technically what they are and how they work. So what data loaders are responsible for is those are how we are pushing that slow, computationally expensive data processing earlier in the pipeline, so that you are generating data snapshots at build time, meaning that your users don't have to experience the slowness of that processing when you click on the app. So we don't, with data loaders, eliminate data, like slow data processes. You might still have like long running models or time consuming database queries. But what they do allow you to do is move them earlier so that those are happening at build time and not after they're deployed. Then that baked data is actually what's getting shipped. Again, that's what allows this faster loading of data visualizations and pages is that pre-baking the data, sending that in a package to your end users. There are a couple of philosophical points, which I'll be excited to hear folks' questions about because they usually come up, that we think are important to think about conceptually, that we think are strengths of data loaders. First, we think that only data that is required for a page to actually load and run should be sent to the client. So that means if you're preparing data visualizations, only data that's actually used in charts on that page should actually be like generated, shipped, and then loaded client side. If there's any excess, then that can just contribute to slower page loads. And kind of similar to that is that we are also proponents at Observable of opinionated dashboards. This is something that we have a lot of conversations about is if you are pre-baking data snapshots that then get sent to the client where people can interact with the data visualizations that they're used to create, then doesn't that mean that you are restricting the amount of data and the number of options that an end user could possibly explore? And the answer is yes. And we feel good about that. So we actually think that restricting what data is available for visualizations is actually a good thing for dashboard design and decision making. The opposite of this is a data app, for example, that queries live from a database that allows a user to explore any possible combination of variables and values that they could imagine. That can be one, slow, but two, oftentimes can open this like Pandora's box of options that leave a user feeling a little bit more lost in the weeds of the data rather than a more opinionated dashboard that can help users focus on the most important outcomes. So when you write data loaders, you have to be really thoughtful about what data is generated and then shipped. And that means that you're really nudged towards this more careful design of opinionated dashboards that can help viewers focus on more meaningful changes or outcomes. And we think that that's really a strength of data loaders is that encouraging more careful and opinionated dashboard and data app design. Now, technically, what are data loaders and how do they work? I think this is so cool. All right, so at the simplest level, data loaders are just programs that you can write in any language you want that generate a static data snapshot at build time. So that's it. Every data loader does this thing. That means that a data loader can be a Python script that accesses data from an API, does some wrangling, and returns a CSV. This could be an R script that queries a database, runs some regression, and visualizes the output, then generates an image like a PNG file. That can be a data loader. It could be a query powered by DuckDB that returns an aggregated subset of data in Apache Parquet format. That can be a data loader or truly any other program in any language that can write the output to the standard output stream so that it works with frameworks routing. So that's really all a data loader is. It's a program in whatever language you love that generates a data snapshot, which is then sent to the standard output stream to work with frameworks routing. So, for example, it can compare a cached version of the data with updates to the data loader so it knows if it needs to be rerun, for example. But any program that can generate output and send it to standard out, that is a data loader. So now I want to look at one simple but concrete example so you can see kind of how this works and to demystify what a data loader looks like a little bit. This is a little Python data loader that does some basic data wrangling on the Penguins data set and then writes the output as a CSV. So I'm going to break down the different parts because there's only a couple of things that I think might look unusual. And the first is this double extension, which I hadn't seen before, but I think is really nice. So this file name for this data loader that would be in my framework data app project that I'm creating has the file name myloader.csv.py. So notice that double extension. So that double extension indicates one, the output type, so that's a CSV, and two, the loader language, here Python. So that's why we see that double.csv.python extension, indicating that this is a Python data loader that's going to generate a CSV. So that's the first thing that might look a little bit unusual, but then you get into the familiar stuff. So the data loader's main body here is where you would load any libraries you need, do your data access, wrangling, and modeling as usual. So there's no surprises here. And again, this is language agnostic. This could be in R, SQL, Rust, Go, Ruby, TypeScript, whatever language you want. And that's the core of the data loader, is just where you're doing this data pre-processing. And then finally, like I was saying, to work with frameworks routing to make sure things get correctly built, cached, et cetera, the output is sent as a CSV to the standard output stream. And this is a data loader. So this will generate at build time the output of this Python code, and then only that generated data snapshot would be part of the bundled static site that gets sent to the client. Now, what does this allow us to do? Because we're doing all this pre-processing is happening at build time, that lets us make stuff like this, which is an interactive chart that visualizes 7.5 million requests to our observable servers that loads almost instantly. Now, this, if we were trying to do this all client side, this was taking like over 30 minutes to try to have this visualization run, and then trying to interact with it, not even a possibility, right? But with data loaders, we can push that time consuming, computationally expensive stuff to build time so that when we actually interact with it, when we open the link to this app, this loads almost instantly. And I've added a link to our framework docs, which has multiple examples, including this one, where you can test it out and see how quickly this loads. And also because there are times, right, where there are cases where you don't just want something to be available if it's been pre-packaged. There are situations where you absolutely do want an end user to be able to live query something from a database or rerun a model. And in that case, you can absolutely still do this with framework. Like write in a markdown document. You can use Fetch or WebSocket. You could use like DuckDB in Markdown to actually do some live querying. So you're not restricted to pre-processing all of your data. But the way that framework can make things really fast that otherwise aren't is using data loaders to front load the data processing to build time. Now, the other part of framework that can make things really fast is our static site architecture. So we've learned about writing data loaders in framework that can push our data access, processing, and analysis to build time. But it's also fast because of this static site architecture, which essentially, in addition to the data loaders running to generate these smaller sets of static files or data snapshots that get shipped to the client, the entire site is packaged up beforehand for even faster page loading. That includes code, configuration files, pages. We also, in addition to data loaders, have page loaders that you can build, which is another really cool thing that I don't touch on here. And all of that is meant to reduce your processing that has to happen when a user opens that page so that they have a faster and better experience, both with faster load times and with more fluid interactivity. So it's really those two things combined, data loaders and that static site architecture, to pre-bake as much about your data and the app as you possibly can before it gets to the end user, that make framework data apps and visualizations so fast and so nice to interact with once a person actually opens your app. And just because today happens to be our launch day at Observable, we now offer embedded analytics. So you can now export things that you've made in Framework as modules or files to embed those into your existing website or host applications. So that means that you can create stuff like using data loaders and using D3 and Observable Plot to create these really awesome, super fast visualizations in Framework and embed those to keep the benefits of Framework, but without having to reinvent your entire site from scratch. So, to summarize, we are not saying that we make all of your data processing and analysis instantaneous. Even your builds might still take a long time. But what we're offering with Framework is a way to deliver the fastest, richest data apps so you don't have to make a trade off between like the awesome apps of your dreams and performance by pushing slow processing behind the scenes to build time, so that you can really have your cake and eat it too with great visualization and really speedy apps. So we think that getting data past the last mile shouldn't have to be that demoralizing experience where you have to sacrifice your great ideas for visualizations or abandon your dreams of super fast apps or abort your mission to give your users richer insights. With Framework's baked data architecture, you really can push slow stuff to build time where it goes unnoticed by viewers so that you can really joyfully get your data past the last mile. And with that, that's all I have for today. So thank you so much for joining me for this talk.